Hello from West Virginia. Okay, I'm somewhere anyways. Alright, joke of the day, because I know you've been waiting for joke of the day. You know, I asked the football coach what position I could play on the team. He told me I'd be a drawback. Because, you know, on football teams they have a quarterback, they have a defensive back, they have a running back, a linebacker, and I'm going to be a drawback. Okay, you know what's not a drawback is being able to factor. So we're going to take a look at 4 polynomials and be able to factor those 4 polynomials. Now we have talked about being able to factor 4 polynomials before, and what we said was, say for instance in this example, we said we would put pairs together and we would factor out what's common from those pairs. So like for instance in this example, I would try to put these 2 together, and then I would try to put these 2 together, and I could certainly factor a 4 out of these, and we'll even factor out a negative 4, leaving, or sorry, let's go with a positive 4. No, let's go with that, sorry, a negative 4, leaving me with a positive u minus 1. But remember, I need to be able to take the other pair and be able to factor out something common so that I get a parentheses that is identical. That's clearly not going to happen here. But we said, okay, when that doesn't happen, the other thing that we could do is we could rearrange and regroup, put other terms together. So let's say, for instance, that since this is not going to work the way it's already lined up, let's say that we put together perhaps, let's put the u squared together with that minus 4u. Let's put the minus 4v squared together with the plus 4. So in this pair, I'd be able to factor out a u, giving me a u minus 4. And notice that when I put these pairs together, even if I factor that 4 out, that's leaving me with a v squared plus 1. I don't have a common parentheses yet again. So let's say instead, I put together the u squared with the 4. So then I'll go u squared plus 4. Notice I can't even factor anything common out of there. So I'm not able to take this 4 polynomial and break it up into pairs and factor what's common out of each pair, leaving me with a common parentheses that I can divide out. So what's a girl to do at this point? Well, go back to one of the one of the things we learned before in factoring whenever we saw something like this, an a squared minus b squared. Now remember, when we saw a squared minus b squared, we called that a difference of squares. And when we had a difference of squares, we said we could factor it into a pair of binomials. We said that the minus right here would indicate that we have opposite signs. One's a plus, one's a minus. And we would take that front term and we'd split it up into the front slots as an A and an A. We'd take the back term, split it up into the back slots as a B and a B. And then voila, that's how you factor your difference of squares. Because remember, when we FOIL this, a times a will be a squared. And on the outside, we'll get a negative AB, and on the inside, we'll get a positive AB. Those will cancel out, and then we multiply b times negative b, we get a negative b squared. So this is how we're going to factor a difference of squares. The reason I bring this up is because you can take the 4 polynomial, and you can create a difference of squares out of it. Here's how you do it. Let's say that I'm going to take the squared term here, and the squared term here and slide it way in the back. And then I'm going to take 3 terms here and create a binomial squared. Because when I create a binomial squared and combine it with this, believe it or not, I have a difference of squares sitting there. And I can factor the difference of squares just like I did right up here. So what I'm going to do then is, instead of creating pairs, I'm going to put together a triple by putting these 3 terms together. This one, these 3, or sorry, those 2, and then slide that minus 4v squared back by itself. And then I'm going to factor this triple. Now, in order to factor the triple, there's nothing common that I can divide out, and you always do that first. So then I'm going to head for that double parentheses, and when I head for the double parentheses, this back sign here is telling me the signs are the same. This sign's telling me they're both minuses. And then I will split this up as a u and a u in the front slots. I'll split up my 4. Now I could do a 4 and a 1, or I could do a 2 and a 2. If I could do a 2 and a 2, probably that's what's going to be. And notice that when I do factor it that way, u times u is u squared right there. On the outside I get a negative 2u, and on the inside I get another negative 2u. Those two, in fact, do combine to be that minus 4u squared, and in the back, a negative 2 times a negative 2 is a positive 4. So this is, in fact, the correct way to factor that. But if you'll notice, I have identical parentheses. And we've talked before about when you see a parentheses times a parentheses, or in other words, a quantity times itself, then you write it as quantity squared. So that means I'm going to write this as quantity squared. And so that gives me my difference of squares. Now I'm not going to forget my minus 4v squared back here. Now it may not feel like a difference of squares, but remember what I really have here is quantity squared, and here this is actually going to be a 2v squared. Because remember, if I take a 2v and square it, that means I'm going to take the 2 and square it to get a 4. I'm going to take the v and square it to get a v. So here is my difference of squares. Quantity squared, quantity squared. So therefore, when I try to factor a difference of squares like you see right here, remember what I'm going to do is split it up into double parentheses. So when I split this up into double parentheses, notice that I'm going to take this back sign. It's going to tell me that I'm going to have a positive and a negative. Same thing's going to happen right here. One is a plus, one is a minus. I'm going to take what's being squared right here and I'm going to split it up into the front slots. Now what's being squared here is parentheses. So I'm going to put parentheses here, and then what I'm going to do is in the back slots, I'm going to take this term. So what's being squared here is a 2v. So I'm going to put my 2v here and my 2v here. Now notice that what's inside that parentheses, remember, is a u minus 2. So this is a, oh, let me clean this up a little bit. That's kind of ugly looking. A u minus 2 in that parentheses. And then I have a u minus 2 in this parentheses. And so since I've got a parentheses in there, technically these should be brackets, technically. But notice that within this bracket right here, it's really just a u minus 2 plus a 2v. So I don't really need that parentheses sitting there. It really is just a u minus 2 plus a 2v, and the same thing in this bracket. It's really just a u minus 2 minus a 2v. So I could just leave out the parentheses there and call it a u minus 2 minus a 2v, and then the same thing could happen right here. So I don't necessarily need the brackets. The only reason I put them there was to illustrate that where I got this part was from that parentheses. And this is actually how you factor it. Because remember, factor means I have two things multiplied together. What do I have multiplied here together? Parentheses times parentheses. There's the two things being multiplied together. Now remember, you can always check this by taking this and multiplying it out. When you multiply it out, you had better get back to the beginning. If you can't get back to the beginning, then it's not right. Notice that when I multiply this out, I'll take a u times a u, and I'll get a u squared. And this is going to be my check. And when I take a u times a negative 2, I get a negative 2u. And when I take a u times a negative 2v, I get a negative 2uv. Now I'm going to take this negative 2 and multiply it through. Negative 2 times u is a negative 2u. And a negative 2 times a negative 2 is a positive 4. And a negative 2 times a negative 2v is a positive 4v. And now it's this guy's turn. Let's send him through. 2v times u is a positive 2uv. And a 2v times a negative 2 is a negative 4v. And then finally a 2v times a negative 2v is a negative 4v squared. Notice here that any like terms, I have a negative 2u and a negative 2u. Those will combine up to be a negative 4u. Whoa, right there. And then a negative 2uv plus a 2uv will cancel out completely. And then this positive 4 is sitting right there. And then notice my 4v minus a 4v, those as well will cancel out. And so here is my u squared, and here is my minus 4v squared. So you see that I do in fact get right back to where I started. Remember, this is just the check. The answer is your factored form right there. So the idea again is whenever you've got your four polynomials, first try to separate them out as a pair and a pair, and then factor out what's common to each pair, and then leave you with common binomials that you can divide out. But if that won't work, especially when you notice you've got a squared term minus a squared term. And then you have a first power of one of the squared terms, and then this constant. Oftentimes you can put it as a triple and factor the triple as a binomial squared. And then especially if there is a minus on one of those squared terms, it will create a difference of squares. So let's try one more, because you know that I like for you to get lots of examples so that you feel comfortable with it. So as we take a look at this one, similar idea happening here. I could attempt to put it together as a pair and a pair. If I pair this one up, I'll get a u times a u plus 2. And there is no way here that I can get a u plus 2. Remember, I'm looking for that common parentheses. So when that's not going to happen, I can say, well, let's try to pair them up in a different way. So let's try to put my u squared minus my v squared together. Now that would be a u plus v and a u minus v. But when I try to put together my 2u plus 1, that's not going to do any good at all. There's nothing that I can do to create a parentheses times a parentheses. So I'm certainly not going to pair them up that way. And then as we've discussed before, if I try to put together the u squared here with the positive 1, I can't even factor it. So I think instead I'm going to create my triple like I did before, saying u squared plus 2u plus 1. And then let my minus v squared sit back here by itself. I'm going to factor this triple. Now notice there's nothing common that I can divide out of each one of them. So what I'm going to do is set up my double parentheses. This back sign tells me they're the same. This means both pluses. And so now what I'm going to do is split this up into the front slots as a u and a u. Split this up as the back slots. There's only one way to split up a 1. And notice when I do check my outsides and insides, I get a 1u and another 1u. So u plus u will give me my 2u. This is the correct way to factor it. But remember, what I wanted to point out is that when you see a quantity times itself, very important that you write it as quantity squared. Because now I have my difference of squares. I kind of sort of don't care what's inside that parentheses. It is parentheses squared minus v squared. Aha, there is my difference of squares. And so when I have that difference of squares, the way I'm going to break it up is I'm going to say, let's split it up as back sign telling me I want opposite signs. This one's easy to split up as a v and a v. Now I'm going to take this and split it up as parentheses and parentheses. Just remembering that what's inside that parentheses is a u plus 1 and a u plus 1. And as I discussed before, since it's just a u plus 1 plus a v, I don't really need this parentheses anymore. It was just helping me to understand what went in that slot. And the same thing here. It's a u plus a 1 minus a v. I don't really need this parentheses here either. And so now here is my factored form. Beautifully done. And once again, we can check this. When we do u times u, we get a u squared. When we do u times 1, we get a plus u. And u times negative v is a minus uv. And then here, 1 times u is u. And then 1 times 1 is 1. And 1 times minus v is a minus v. And then here, v times u is a uv. And then v times 1 is v. And then v times minus v is a minus v squared. Now, when I look for those like terms, here is u plus u will be a 2u. And then minus uv plus uv cancels out. And then my minus v plus v cancels out. So I've got my plus 1 sitting here, my minus v squared sitting here, and my u squared sitting here. I do get back to where I started. So I know, in fact, yes, this really is the right answer. So I hope that helps with being able to factor your 4 polynomials into a difference of squares. Remember, try to pair them up first. If they don't pair up and you cannot take 2 terms and 2 terms, factor out what's common and leave those common binomials that you can factor out. Then certainly triple it up, factor your triple as a binomial squared, leaving you with a difference of squares that you can factor into your difference of squares. I hope that helps. Have a great day.